This is an impedance analyzer for testing ultrasonic devices and equipment, with a power of 30 watts and a maximum test frequency of 5 MHz. Next, we will demonstrate how to use this impedance analyzer to test the 20 kHz transducer with mold. Step 1. We plug in the power supply, and turn on the switch on the left side of the impedance analyzer. Step 2. After turning on the switch, select Chinese or English as the language and enter the operating interface. Step 3. Connect the two ends of the fixture to the two ports of the transducer wire. The red wire to the positive pole, and the black wire to the negative pole. Make sure they do not contact each other. Step 4. Set the start and end frequencies. We are testing the 20 kHz transducer, so we can set the range, 19 kHz for the start frequency, and 21 kHz for the end frequency. Step 5. Set the detection accuracy. There are 6 levels: fast, normal, medium, high, higher, and highest. If the mechanical quality factor QM of the ultrasonic device is low, select the lower level. If QM is high, select the higher level. The higher the level, the more points are measured, and the time is longer. Here we have set the level, normal for demonstration. Step 6. There is a start button on the analyzer, see here, and on the screen. The start button is the run button here, just press one of them to start. Press the start button to start the measurement, and the progress bar shows the progress of the measurement. We see that the graph displayed on the left side of the screen is not a circle, at which point the accuracy needs to be increased by one level for testing again. This is the graph at the medium level. This is the graph at the high level. This is the graph at the higher level, and this is the graph at the highest level, where the screen shows a complete circle with the trough and a peak on the right. Now this is the correct test. Then, we will describe the parameters of the impedance analyzer. 1. Fs stands for resonant frequency, representing the frequency at which the impedance of the piezoelectric oscillator is minimized. 2. R1 stands for resistance. 3. Fp stands for the anti-resonant frequency, at which the impedance of the piezoelectric oscillator is at its maximum. 4. Qm represents the mechanical quality factor. 5. Ct stands for free capacitance, which is the capacitance value of a piezoelectric device at 1 kHz. 6. L1 is the dynamic inductance, the inductance of the serial branch of piezoelectric transducer. 7. C1 stands for dynamic capacitance, the capacitance of the serial branch of piezoelectric transducer. 8. CO stands for static capacitance, and CO equals Ct minus C1. 9. Kef represents the effective electromechanical coupling coefficient. 10. Kp stands for the end-plane electromechanical coupling coefficient. This parameter is only used for piezoelectric ceramic plates. 11. F1 and F2 represent the half power point from the conduction circle. Greater than Fs is F2, and less than Fs is F1. 12. GMAX represents the maximum conductance. The real part of the conductance value of a piezoelectric oscillator at resonance, that is the real part of the conductance at Fs. That's all for the parameter explanation. There are 3 terminals on the analyzer right side, from top to bottom to display. 1. USB terminal, used to access to the U-disk to store the measurement date or save the parameter sheet in Excel form. 2. 232 terminal 1, used to connect the PLC and the instrument communication. 3. 232 terminal 2, used to connect the computer and the instrument communication. That's all for the impedance analyzer. If you have any questions, feel free to contact us.